All right, let's dive right into this explainer. I want you to picture a high-traffic server environment, the kind of place where code quality and lightning-fast responsiveness are literally the only things that matter. Today, we're exploring a seriously fascinating aspect of modern programming known as the secret life of Python. Specifically, we're going to look at why you must never, ever block the Asyncio loop. We'll break down exactly why CPU-bound code completely freezes your server and the brilliant ways we can fix it.
Section 1. A small, costly mistake. So let's meet Timothy. He's a junior developer, and frankly, today he's feeling absolutely invincible. He just successfully wrote some code to juggle requests from 3 simulated users, Alice, Bob, and Charlie, using Python's Asyncio. Everything was flowing perfectly, and the system was incredibly responsive. But then, as developers often do, he decided to add just one more little feature.
He told his senior colleague, hey, it's just a small calculation. I'll just run a heavy for loop to generate a secure token. He decided to add a security hash to Alice's request. And honestly, his logic seemed pretty sound at first glance. He assumed that because this heavy 2-second math calculation was placed inside an async function, the Asyncio system, which we can visualize as this master juggler, would just magically handle it in the background while waiting for Bob and Charlie's requests.
Well, the screen stayed completely dead. Timothy had accidentally added what turned out to be a selfish loop exclusively to Alice's request. He hit enter on his keyboard, fully expecting that usual buttery smooth concurrent processing where Bob and Charlie would start right up. But instead, the entire system just stopped cold. I mean, literally, nothing happened.
To put this into perspective, look at this timeline. At 0 seconds, Alice starts her heavy math, and then we just wait. A full 2 seconds pass. It wasn't until the 2-second mark, when Alice entirely finished her math, that the system actually woke back up. Only at 2.1 seconds did Bob and Charlie finally appear. Bob and Charlie were essentially left standing there in the digital cold for 2 full seconds, totally unable to start.
Moving right along to Section 2, the juggler's hands. At this point, Timothy is practically crying out in frustration. Alice had frozen the whole stage. His senior colleague, Margaret, steps up to explain exactly what went wrong with the system's architecture. Timothy is completely baffled, and he asks a really great question. Why didn't the event loop, our juggler, just pause Alice's math to start Bob and Charlie's requests? In his mind, if someone is taking too long, the juggler should just toss that ball up in the air and catch the next one, right? Why couldn't the system just multitask?
Margaret points out a massive, absolutely crucial distinction between waiting and working in async I/O. When a task is just waiting, like waiting for a database to reply, which we call I/O bound, the juggler can totally toss that ball in the air. Their hands are completely free to catch other balls. But heavy math? That's not waiting. That is working. When the system does heavy math, the juggler has to hold that ball super tightly with both hands, focusing 100% on that one calculation. They literally couldn't free their hands for the others, even if they wanted to.
Which brings us to Section 3, the cardinal sin explained.
Margaret makes it crystal clear. Timothy committed the ultimate cardinal sin of Asyncio. Blocking the thread with heavy work stops the event loop for absolutely everyone. Think about it. By doing heavy work directly on the main stage, one selfish player didn't just slow down their own process. They crashed the experience for your other 4,099 users. Every single person connected to that server just has to sit and wait while Alice finishes her math.
Section 4. Offloading to the specialist.
So, Timothy, feeling pretty defeated, asks if this means he just can't do math in Asyncio at all. Margaret explains that of course you can, but you have to send that ball to a completely different stage. If you have heavy lifting to do, you simply cannot force the main juggler to do it. You must offload that work to a specialist. In Python, this specialist is usually a thread or a process. You hand the heavy math off to them, and the main juggler simply awaits the result. That way, their hands stay completely free to keep juggling everyone else's requests.
Section 5. Rules of the loop.
To make sure Timothy never falls into this trap again, Margaret lays out a super helpful triage process. Whenever you write code, you've got to ask yourself 3 simple questions. First, is it doing math? If it's CPU-bound, you have to offload it. Second, is it waiting for a database or an external API? If it's I/O-bound, you're totally safe, just use the standard await. And third, does it use a standard time.sleep command? If so, stop right there. That is a purely selfish command that will freeze the whole thread.
So here's Margaret's cheat sheet for you to remember. The cardinal rule right at the top. Never block the loop. Offload your CPU-bound code and use await for your I/O-bound code. Never ever use time.sleep. Always use await asynchronio.sleep. Oh, and the ultimate escape hatch, which was added in Python 3.9, is asynchronio.to_thread. This is the absolute best modern way to easily run a blocking function in a completely separate thread without ever freezing your main juggler.
As we wrap up this explainer, I want you to take a really hard look at your own code today. Is your asynchronous secretly making 4,999 users wait for one selfish loop? Remember the juggler and really ask yourself if your code is truly multitasking or just holding up the entire stage. It's a real game changer once you get it right. So, what's hiding in your event loop?